All right, I'm going to have you open up your books to page 59, which is this page here. I just wrote it so I didn't have to move the book down. We are going to be working with equivalent ratios today. And when we are working with this word, you probably have a word that comes to mind. Equivalent means equal. Okay, so equal ratios. So it's kind of dealing with fractions and equivalent fractions. It's probably where you have heard of this phrase before, especially this year in math. So I want you to write, think of equivalent fractions. Okay, an equivalent fraction to 1/2 is 2/4 or 3/6 or 10/20. These are all equivalent fractions to 1/2. So ratios, like we said, are considered partly to be fractions. So we can consider a ratio of some sort to have very similar equal parts or setup of ratios as compared to fractions. Okay, so I want you to copy down these notes on here. You don't have to write this, but think about equivalent fractions and write down some examples here. Write that the word equal could be substituted for the word equivalent. All right, so what we are going to be working with is double number lines again, but we're going to be looking at them as ratios more so. Okay, so I want you to flip to the next page. So this is page 60, down at the bottom here, page 60. And we're going to look at some of the examples that they have right here. We are going to be given two different rates or ratios. And you'll notice miles and hours, miles and hours. Those are pretty common ones that we've done double number lines with. And we're going to determine if these guys are equivalent to each other. So 20 and 5 go together. Are they the same, or do they have something in common with 45 and 9? And what that means is they have to both be multiplied by the same number in order to be considered equivalent. Okay, just like 1/2 to 2/4, they're both the denominator and the numerator are multiplied by 2 in order to get that. Okay, so that's what we're looking for. Write each rate as a fraction. Okay, this is what this is saying, but what we're going to do is we're going to find a different way to do this. Unless, let's do our way first. Let's do a double number line off to the side here. And then I have a cool point to show you. Okay, so double number line, we have 20 miles in 5 hours. So I'm going to do miles per hour as my two labels. And we're trying to find the unit rate, okay, or the unit ratio. So 1 hour, how many miles can you travel? Okay, so now we have 20 miles in 5 hours. And we can solve for our unit ratio or our unit rate. So let's find our missing piece between 5 and 1, divide by 5. What I do on one side, I have to do in the other. Divide by 5. When I do 20 divided by 5, this unit rate becomes 4 miles per hour. Okay, now let's solve 45 and 9 over here. We'll do another double number line. Same labels, miles per hour. 1 question mark, those are the same. And now we have 45 and 9. Okay, or I'm sorry, 45 and 9. 9 hours, 45 miles. Okay, divide by 9, divide by 9. 45 divided by 9 is 5 miles per hour. Okay, so now looking at both of their unit rates and comparing them to the other. Are they equivalent? If they are to be considered equivalent, they both have to have the same unit rate. In this case, they do not have the same unit rate, so they would be considered not equivalent. So if this question was saying determine if they are equivalent, you would show me your work, and then you would tell me, no, they are not equivalent. Their unit rates are not the same. But I want to kind of look at what they did here. Look at this, and now I might give you this option. If you want to solve it this way, you can. What do you notice about the way that they solved it here and we solved it this way? Let me focus it a little bit more. You'll see that they put it into a fraction, like they said here. Write each as a fraction. 20 over 5 equals 4 over 1. Okay, so they found their unit rate here. Okay, this is what we solved for. I guess I'll look at this one. This is what we solved for and got up here. So they had to solve for this eventually. But if you look at this and you were to tilt this to its side, this is a double number line, okay? We would have our line here, 2 lines here. We have 1 and question mark, even though these are flip-flop than what we did, but you would still get the same answer. 1 and question mark, 9 and 45. Find your missing piece, divide by 9, you would get 5. Okay, so I just wanted to point that out, that that's kind of a cool thing, and that's why double number lines are so important and easy to use as solving a method. All right, let's look at number 2. We're going to determine if this is a good deal, if these rates are equivalent. So 3 t-shirts for $21, 5 t-shirts for $7. We're trying to see if they're both being multiplied by the same number here, okay? So they set it up as a fraction. I'm going to solve it with a double number line. So we'll do this one over here just to get more room. So we have dollars, or shirts and dollars. Dollars per shirt. And we're trying to find the unit rate of it. So 1 shirt costs how much? We know 3 shirts cost $21. So we're going to divide by 3 like they did here. Divide by 3. We know that 3 t-shirts for 21 is $7 per shirt. Okay, so that's that rate right there. We get $7 per shirt. Let's do the same thing over here. Dollars per shirt. We have how many or how much money does 1 shirt cost? We have 5 shirts that cost $35. Divide by 5. Divide by 5. We get 35 divided by 5, 7. So we get $7 per shirt again. Okay, so now looking at this, they both have the same unit ratio or unit rate. So that means they are equivalent to each other. All right, now let's look at the got it problems down at the bottom. And let's do some of these on our own here. 36 t-shirts in 3 boxes or 60 t-shirts in 6 boxes. All right, let's solve double number lines here. And I'm going to use the space down below just because that's where I'll write my answer. So I'll do some small double number lines here. So we have shirts, boxes as our label. All right, so we know that 1 box is what we're given as our unit rate. We're trying to find how many shirts are in 1 box. We're given 3 boxes and 36 here. Okay, so now we're going to go down. We're going to divide by 3 on this side. 36 divided by 3 gives me 12. So 12 shirts per box. I'm just going to write that above that part here. That's unit rate. Okay, now I'm kind of running out of room, so let's solve this double number line over here. We will do same labels, shirts per box, 1 box, how many shirts? That's the same. But now we're given 6 boxes and 60 shirts. All right, divide by 6. Divide by 6. I get 10 shirts per box for this one. Okay, so I get 10 shirts. 10 shirts per box here, and I get 12 shirts per box here. Are they equivalent? They are not. They're not the same. So I would write no, and then I would show this in my work down here, box your answers, and say unit rates aren't equal. Unit rates aren't equal. Okay, now that would be the explain your reasoning part. That's what we're doing there. And then determining if they're equal or equivalent would be showing what the unit rates are down here. All right, I apologize that space was not a lot of room to work. We're going to write all of our answer right here, how it should be done in the next few problems in your practice and your homework over the next couple days, just so you can see that. So let's set up 2 double number lines here. That way they're easy to compare with each other. And we have 42 flowers in 7 vases, 54 flowers in 9 vases. So I'm going to do flowers per vase, flowers per vase. All right, so we want to find how many flowers you can fit in 1 vase, how many flowers you can fit in one vase. This one, you have 7 vases and 42 flowers. This one, you have 9 vases and 54 flowers. All right, let's solve. Let's see if they're equivalent to each other. So on this side, I'm going to divide by 7, divide by 7. 42 divided by 7, remember we always go in this order here, gives me 6 flowers per vase. Okay, now I'm determining right here, I'm showing that this unit rate is this. Now when I divide this guy, divide by 9, divide by 9, 54 divided by 9 is also 6. 6 flowers per vase. All right, so now we have determined their unit rates, okay? We're determining if they're equivalent. Since they are the same, they are equivalent, so we're gonna explain our reasoning and write, yes, their unit rates are equivalent. And that's what makes them equivalent fractions or equivalent ratios and equivalent rates. All right, now your homework is going to be on the next page, page 62. We're going to do parts of the guided practice here, and you're actually going to do problem 1, 2, 3, and 4 for your homework, not number 5. Okay, so you are going to do 1, 2, 3, and 4 on page 62 for your homework today. Let me know if you have any questions.